Hello guys, welcome back to our ionic compounds and the rules for naming. In this video, we are going to continue talking about binary compounds, but we are now going to focus on binary compounds that have transition metals because the rules change just a little bit when it comes to them. So as a recap, binary, we're talking about composed of two types of atoms. Ternary, as on the screen shows, it's going to be composed of three or more types of atoms. Our next video will be on the ternary rules for ionic compound naming. Now, there are just really two rules that we need to keep in mind when it comes to ionic compounds that include transition metals. And that is the first, still just name the metal. The difference here comes when we have a Roman numeral. Then the non-metal will still be named with the ending of it changed to IDE, as we have done before. Again, here the only difference is that we now have Roman numerals. And the thing we have to keep in mind is that the charges have to equal to 0. And this is important. We will learn eventually how to write the formulas from the name. For right now, we need to know that the charges have to equal to 0 because that charge is what's going to help us determine the Roman numeral that has to go in the name. Now, Roman numerals are used only to indicate which of the charges is chosen for transition metals. And that'll make more sense in just a moment. But the entire idea is that if we need to choose between charges for transition metals, then that means that some transition metals are going to have multiple oxidation numbers. So let's look at a few examples. Here on screen we have copper 1 oxide, copper 2 oxide. And then we kind of see the same pattern in all the other examples. We have tin 2 fluoride, tin 4, then we have on the right side lead 2 and then lead 4. Then we also have iron 2 and then iron 3. So that should give you the clue that when it comes to transition metals, Roman numerals are going to become important because if you just look at them, I mean, it might be very easy for you to say just lead oxide. Well, no, there's different options. And that's what's so important for us to learn in this video. So I want to draw your attention to the first couple of examples, the ones with copper. And I want you to see there that the formula itself is very different. Cu2O and CuO. Now, that little 2 makes a huge difference because that's a different compound. Its properties are going to be different. Its composition is different. The way it will behave will be different. So getting the name, getting the formula is extremely important. Some of these can become very, very destructive to the human body if we were to mix them up. So let's look at some specific examples before we look at some by ourselves. Okay, so if you're thinking about, okay, well, there's going to be multiple oxidation numbers. Am I supposed to memorize this information? The answer is no, not really, but we will use some that you will become familiar with. Right here on screen, we have a portion of the periodic table that I want you guys to take a moment and label. Now, if you recall from our previous lesson, we saw that oxidation numbers for the main groups 1 through 8 is pretty self-explanatory. But when it comes to the transition metals, you don't really truly see a pattern. So right here, I'm going to circle the ones that you must have labeled on your periodic table, or just go ahead and memorize them, but you could just label it. So we're going to label iron 2 plus and 3 plus, nickel 2 plus, 3 plus, copper plus 1, 2 plus, zinc specifically we're going to label it as 2 plus, silver we will label it also as a 1 plus, mercury we're going to label it as 2 plus, and the difference here you may be thinking, well, they both say 2 plus. Well, yes, but one of them has the subscript of 2, so make sure you note that. And right here on the bottom, we have tin as a 2 plus and a 4 plus, and then lead, 2 and 4 as well. As we move forward with the unit, I will give you a few more that you will need to label, but these are the ones that we're going to use the most here for the first couple of days for the lesson. So let's take a moment. Let's go ahead and label all of these on the periodic table. and then we'll move on to some examples. Okay, so let's do some practice. And remember, we need to name the metal first. Then we need to have the Roman numeral, so RM for Roman numeral. And then we are going to have the non-metal. And remember, the ending of it still changes to IDE. Okay? And remember the other rule, they must equal to 0. So that's important. So right here, we have copper and we have oxygen. Copper, as we saw in our previous slide, can have a charge of +1 or 2+. So I'm just going to write them here on the side, +1 or +2. And we know based on our previous lesson that oxygen on the periodic table has an oxidation number of +2. So think about it. The rule is that they have to equal to 0. Which of the two charges for copper would actually make... Oh, I'm sorry, oxygen is not a +2, it's a -2. I do apologize, guys. Which of the two charges of copper is going to make the overall charge equal to 0? Well, obviously, +2, because +2 minus 2 will give us 0. So now that you have figured out which of the two charges for copper is the one that makes the second rule for equal to 0 valid, that's the Roman numeral that you will write. So we're going to write then copper, Roman numeral 2, because the charge of it that makes it equal to 0 is 2, so it's Roman numeral 2, and then just oxygen, but remember we changed it to IDE, so oxide. And actually, I need to take a moment here and give you guys the numbers, because I do know that sometimes students forget Roman numerals or they've never been taught the Roman numerals. So a 1 would just be something that looks like an I, capitalized. 2, 3, 4, IV, 5, just a regular V. And then in very rare cases, almost never, it would be 6, VI. Okay, so those are the ones that we're going to be looking at. And those are the charges, remember, that we're going to be looking at. The oxidation numbers, really. I shouldn't call them charges. Okay, so let's look at the second example. We have copper, but we are being told that we have 2 of them. So whatever charges for copper we need to look at is going to be 2 of them. So on the previous slide, we saw again, copper has either a +1 or a +2. So we're going to do, and because we have 2, right? Either +1, +1, or +2, +2. And I'm writing it twice again because the formula is telling me that there have to be 2. So we also have oxygen, and its charge based on the periodic table is going to be -2. Oh, I keep calling them charges, they're oxidation numbers. And here, remember the rule, equal to 0. So which of the two positively oxidation numbers can make it equal to 0? Equal to 0. So it has to be the charge of +1, because both of them together, right, I have to have 2 because I'm told by the formula that there's 2, will make this statement equal to 0 correct. So we're going to then write copper, Roman numeral 1. And here's where a lot of students get confused. They think the charge has to equal to 2, right? Because +1 is 2. And then they want to write a +2 here, but that's not what the Roman numeral represents. The Roman numeral represents the oxidation number, not how many of them there are. And here, each of the oxidation numbers is going to have a total of charge of +1. So anyway, we continue on with oxide. And then on the third example, we have nickel and we have chlorine. Now, nickel is a transition metal that has 2 possible charges, oxidation numbers, +2 and +3. So I'm going to write them on the side. So +2 and +3. Now the thing here is, because I'm not told with a subscript that there's multiple nickel, so I just write it once. Now for the chlorine, I'm told that there are 2. And based on the periodic table's location, its oxidation number is -1. But I'm going to write it twice because I'm told by the subscript that there are 2 of them. Now again, go back to that idea of equal to 0. The total negative charge here is -2. And the positive then has to be, to make it equal to 0, the oxidation number of +2. So we're going to write nickel, oxidation number, Roman numeral 2, because the charge is 2. And then not chlorine, but chloride, because the ending has to be IDE. So chloride. Perfect. We will look at some examples later in our independent practice. So make sure you look at those and also compare them to the answer key. Thank you guys for watching.